Some machines aren't just built, they redefine what's possible. From tunneling beneath cities to peering into the edge of the universe, these engineering marvels push technology to its limits. But which one truly stands as the most complex creation ever made? The Large Hadron Collider, LHC. Hidden beneath the French-Swiss border, the Large Hadron Collider is the most advanced particle accelerator ever built. Stretching 27 kilometers underground, it uses powerful superconducting magnets cooled to temperatures colder than space to steer protons at nearly the speed of light. When these particles collide, they recreate conditions from the early universe, allowing scientists to study the fundamental building blocks of matter. One of its greatest achievements was confirming the existence of the Higgs boson in 2012, a discovery that helped explain how particles gain mass. The LHC continues to push the boundaries of physics, exploring dark matter, antimatter, and forces beyond the standard model. Every run brings new insights, reshaping our understanding of the universe at the most fundamental level. International Space Station, ISS. Orbiting 400 kilometers above Earth, the International Space Station is the largest structure ever built in space. It exists because of a global effort with NASA, Roscosmos, ESA, JAXA, and CSA working together to design, build, and maintain it. Unlike traditional spacecraft, the ISS wasn't launched in one piece. Instead, it was assembled in orbit over several years, with modules delivered by rockets and carefully connected in microgravity. This floating laboratory hosts experiments that would be impossible on Earth, from studying how the human body adapts to space to testing new materials and growing plants without gravity. Every mission adds to our understanding of long-term space travel, laying the groundwork for future missions to the Moon and Mars, while deepening our knowledge of life beyond Earth. James Webb Space Telescope, JWST. The James Webb Space Telescope is the most powerful observatory ever sent into space. Unlike Hubble, which orbits Earth, Webb operates 1.5 million kilometers away, where Earth's heat and light won't interfere with its instruments. Its massive gold-coated mirror, made up of 18 hexagonal segments, unfolds in space to capture faint light from galaxies formed over 13 billion years ago. What makes Webb revolutionary is its ability to see in infrared, allowing it to peer through cosmic dust and reveal details hidden from other telescopes. Deploying such a complex machine so far from home required flawless engineering, as there's no way to repair it. Every part had to work perfectly, from its sun shield the size of a tennis court to the delicate alignment of its mirrors, making it a masterpiece of modern astronomy. Deep-sea drilling vessel, Chikyu. Chikyu is one of the most advanced drilling ships ever built, designed to reach the Earth's mantle, a layer no human-made machine has ever accessed. Unlike standard drilling vessels, it uses a riser drilling system that stabilizes the borehole and withstands extreme pressure from the ocean and shifting tectonic plates. Its ability to drill several kilometers beneath the seabed allows scientists to study Earth's deep interior and the forces that drive earthquakes and tsunamis. By extracting core samples, researchers analyze the movement of geological faults, improving predictions for natural disasters. Chikyu's work is crucial for understanding how stress builds up along fault lines, particularly in regions prone to major quakes. Every expedition brings new data that helps improve early warning systems and deepens knowledge of Earth's inner workings. The Saturn V rocket. The Saturn V remains the most powerful rocket ever built, designed to send astronauts to the Moon during the Apollo program. Standing over 110 meters tall, it relied on a three-stage system to gradually shed weight and increase speed as it climbed through Earth's atmosphere. The first stage generated an immense 7.5 million pounds of thrust, burning through its fuel in just under 3 minutes. The second stage pushed the spacecraft into orbit, while the third provided the final boost toward the Moon. Every part of this rocket was built for precision, ensuring that the Apollo missions reached their destination safely. Its engineering was decades ahead of its time, proving that human spaceflight beyond Earth was possible. To this day, no rocket has surpassed its raw power and flawless mission record. The Hubble Space Telescope. The Hubble Space Telescope changed the way we see the universe. Unlike ground-based telescopes, it orbits above Earth's atmosphere, capturing crystal-clear images of distant galaxies, nebulae, and exoplanets. Shortly after launch, a flaw in its mirror blurred its vision, but astronauts on a space shuttle repaired it in orbit, proving that space-based technology could be maintained. Over the years, multiple servicing missions upgraded its instruments, extending its lifespan and improving its capabilities. Hubble has provided evidence of black holes at the center of galaxies, helped confirm that the universe is expanding at an accelerating rate, and revealed planets beyond our solar system. Decades after its launch, it continues to send back breathtaking images, shaping our understanding of space and paving the way for future telescopes. The Airbus A380. The Airbus A380 is the largest passenger plane ever built, capable of carrying over 800 people in an all-economy configuration. Its four-engine design provides the power needed to lift its double-deck structure, while an advanced avionics system ensures smooth operation despite its massive size. Unlike smaller aircraft, manufacturing the A380 required assembling parts from different countries, with wings from the UK, fuselage sections from Germany, and final assembly in France. This logistical challenge made production costly and complex. Maintaining such a large plane also required airports to upgrade runways, taxiways, and gates to accommodate its size. Though production ended due to shifting airline demands, the A380 remains an engineering marvel, offering unmatched comfort and efficiency in long-haul travel, ensuring its place in aviation history. The Mars rovers, Curiosity, Perseverance, Spirit, Opportunity. NASA's Mars rovers are some of the most advanced robotic explorers ever built, each designed to uncover the planet's secrets. Spirit and Opportunity, launched in 2003, outlived their expected missions, sending valuable data about Martian terrain. Curiosity, arriving in 2012, introduced nuclear power and a mobile laboratory capable of analyzing rock samples for signs of past life. Perseverance, which landed in 2021, took things further by collecting samples for future return missions and testing oxygen production from Mars' atmosphere. Landing these rovers was a major challenge, requiring a sky crane system to lower them safely onto the surface. Each rover carries cutting-edge instruments, from cameras mapping the landscape to lasers and drills, analyzing the planet's geology. Their discoveries continue shaping plans for human exploration of Mars. The SR-71 Blackbird. The SR-71 Blackbird was designed for one purpose: speed. Built during the Cold War, it was the fastest operational aircraft ever made, reaching speeds over Mach 3 while flying at altitudes above 80,000 feet. At that speed, friction with the air heated its body to extreme temperatures, so engineers used titanium instead of traditional aluminum. To reduce detection by enemy radar, its sleek, black design absorbed signals, making it one of the first stealth aircraft. Instead of avoiding missiles by maneuvering, it simply outran them. No SR-71 was ever shot down, proving its effectiveness. Maintaining the plane was a challenge, as its fuel leaked when stationary due to expansion gaps designed to seal at high speeds. Decades later, its engineering remains unmatched in aviation history. The ITER nuclear fusion reactor. The ITER project is a massive global effort to create a working nuclear fusion reactor, a technology that could provide nearly limitless clean energy. Unlike nuclear fission, which splits atoms, fusion mimics the sun's process by fusing hydrogen isotopes at extreme temperatures, over 150 million degrees Celsius. Containing something that hot is impossible with ordinary materials, so ITER uses powerful superconducting magnets to control the plasma inside a donut-shaped chamber called a tokamak. These magnets, cooled to near absolute zero, generate intense magnetic fields to keep the superheated plasma from touching the reactor walls. The challenge is maintaining stable fusion long enough to produce more energy than it consumes. If successful, ITER could revolutionize energy production, offering a cleaner and more sustainable alternative to fossil fuels and conventional nuclear power. The Bagger 293 Bucket Wheel Excavator. The Bagger 293 is the largest land vehicle ever built, standing over 30 stories tall and weighing 14,000 tons. Designed for large-scale mining, it uses a massive rotating wheel lined with buckets to scoop up tons of earth in a single motion. Unlike conventional excavators, it doesn't rely on tracks or wheels, but moves on enormous crawlers, allowing it to traverse open-pit mines efficiently. Operating such a machine requires careful coordination, as even a slight miscalculation can disrupt mining operations. Despite its size, it runs with surprising precision thanks to an advanced automation system that optimizes digging patterns. Transporting and assembling it is another challenge, often requiring months of planning. Its scale and engineering make it one of the most impressive machines ever used for excavation. The IBM Summit Supercomputer. IBM Summit is one of the most powerful supercomputers ever built, capable of performing over 200 quadrillion calculations per second. Unlike regular computers, it processes vast amounts of data simultaneously, making it a key tool for artificial intelligence, complex simulations, and scientific research. With thousands of processors working together, it handles petabytes of information, allowing scientists to model climate changes, study the behavior of viruses, and simulate nuclear reactions. During the COVID-19 pandemic, Summit helped identify potential drug compounds by analyzing molecular structures at speeds no human team could match. Its ability to predict extreme weather patterns and refine climate models also makes it essential for environmental research. Every calculation it performs pushes the limits of what's possible in medicine, physics, and engineering. The F-35 Lightning II fighter jet. The F-35 Lightning II is one of the most advanced stealth fighters ever developed, designed to handle air combat, ground attacks, and intelligence gathering. Unlike traditional jets, it uses sensor fusion to combine data from multiple sources, giving pilots a real-time battlefield picture. Its vertical takeoff and landing capability allows it to operate from aircraft carriers and remote bases without long runways. Advanced stealth technology makes it nearly invisible to enemy radar, while artificial intelligence assists pilots by processing threats and suggesting tactical moves. The jet's software is constantly updated, improving its performance with every mission. With unmatched situational awareness, cutting-edge avionics, and seamless AI integration, the F-35 gives its operators a major advantage in modern warfare, making it one of the most capable fighter jets ever built. The Bertha Tunnel Boring Machine. Bertha was one of the largest tunnel boring machines ever built, designed to carve a massive underground passage beneath Seattle. Weighing over 6,000 tons and measuring 57 feet in diameter, it was created to dig the Alaskan Way Viaduct replacement tunnel. Unlike traditional excavation methods, Bertha used a rotating cutter head with sharp steel discs to grind through soil and rock, while a hydraulic system maintained pressure to prevent collapses. Despite its size, precision was key, as engineers had to guide it beneath existing buildings without causing structural damage. Mechanical issues halted progress for 2 years, requiring extensive repairs. Once restarted, it successfully completed the tunnel, proving how advanced engineering can overcome extreme challenges in urban construction. Bertha's success reshaped Seattle's infrastructure, setting new standards for tunneling technology. The SKA Square Kilometer Array Telescope. The Square Kilometer Array, SKA, is the largest and most powerful radio telescope network ever built. Instead of a single dish, it uses thousands of antennas spread across multiple countries to capture radio signals from space. This design allows it to detect faint signals from the early universe, helping scientists study black holes, dark matter, and the origins of galaxies. Processing such an enormous amount of data requires extreme computational power, with real-time processing systems handling exabytes of information. Advanced algorithms filter out interference and reconstruct cosmic images with unmatched clarity. The SKA will provide insights into cosmic phenomena that optical telescopes cannot see, offering a deeper look into the structure of the universe. Once fully operational, it will transform our understanding of space and time. The world's most complex machines are pushing the limits of technology. Which one do you think stands above the rest? Drop your thoughts below.